What we're interested in doing here is we're interested in capturing the situation where after a certain number of time unit, after a certain age, certain amount of time after coming in, people retire. We could have, you go after 65 years from here, go after 65 years from here, but if people are going back and forth between these states, because that's 65 years after entering this particular state, people are not going to be retiring at age 65. Almost no one's going to retire because they keep on going back and forth, resetting the retirement clock. It's as if they said you could only retire in Canada after 65 years of working at the same place. And then people get laid off from one place to go to another place. No one ever reaches retirement.
You have to put a state in there for moving to the States.
Believe me, it's worse south of the border. Okay, so what could we do? Well, one thing we could do, ladies and gentlemen, we can recognize that basically what's going on here, what we're trying to capture, is the fact that people retire 65 years after being working, or being in sort of the working inclination. They're 65 years after sort of seeking work or desiring work. So we could create a state that includes both unemployed and employed, which is kind of work seeking or seeking employment. Okay, and that's not quite the right word, but employable. Thank you. Okay, so we could have a sort of employable state here, right? And this employable state could then be a super state of employed and unemployed, okay? Now, because of the semantics of AnyLogic, I need to be a little bit careful here. First of all, there's kind of this, I'm not sure what that weird transition is. Yeah, it's something. Okay, so what I'm going to actually do is I'm going to drag this guy into there. I'm going to drag this guy into there, and I'm going to drag this guy over to here, and this thing looks really so ugly that okay, well, maybe I'll let sleeping dogs lie. Okay, so forgive my my aesthetic offenses here. Okay, so now we don't need two transitions here. What can we do? Now that we have this super state, what can we do? We have one transition from here, one transition from here. This logic won't work if this was after 65 years, this was after 65 years. Instead, what can we do? One from employable, right? Okay. So, ladies and gentlemen, let us make one transition from employable, and that transition goes off after 65 years. Okay. Now let's see if it actually likes this, because I've had trouble. Okay. So there we go. So now we have a situation where people are unemployed and employed, but they're fundamentally in the same employable category, and then after 65 years they retire. Okay. And I'm just going to go copy this. Ooh. Oh, gosh. I'm not sure my aesthetic offenses have been decreased. Okay. So let's go. Okay. Well. Okay. So, oh gosh. Okay. Well, what can I say? I'm an engineer. Okay, you'll forgive me, I think. Okay, so here we're going to run this. And here we have this situation where people are in this state. You notice that the highlighted thing indicates they're currently in this state. They haven't yet retired. Some were retired at first, some because there is still this transition. But you'll notice that people are kind of bouncing back and forth because of this. And now we're capturing this individual over time. Watch as their years fly by. So they're getting into their 40s, now their 50s. Okay, they're starting to get closer to retirement here. Okay, here they're getting close, and boom, they retired. They're in They were in these states before, and now they've gone to this retired state. And now if we go and we look at the population as a whole, we get a uniformly retired population. So in short, we can have hierarchical states, ladies and gentlemen, with that, and that's hierarchical states lend us an economy of mechanism when it comes to representing shared logic, logic that would otherwise need to be duplicated with respect to coming from multiple states, for example. You could have that logic instead with respect to the whole superstate, as it were, in this case, employable. So instead of having those transitions from unemployed and employed, you just have one transition from employable. Simply with a death transition, which could occur from any transition. Remember, like in our system dynamics models with those stocks, where we had the mortality transition representing death, we had to have it from every stock. Remember that? Every stock in turn. This is kind of a way to avoid that kind of just reduplication by instead having one transition from the superstate. Okay, it would be almost as if in a stock and flow diagram you could draw a box around this sort of a super stock, and you'd have one exit from there representing mortality. That would be kind of similar to this, but this gives it an economy of expression, ladies and gentlemen. But also, in this case, the semantics are captured in a way they weren't if this transition. If we had had this transition, this timeout at 65, if we had had that coming from each of these states in turn, unemployed and employed, that wouldn't have worked, because each time it would have been reset when they went back and forth between these states, because it's 65 years after entering the state that would fire, exactly 65. So instead, we have it with respect to this employable state, and since we never leave the employable state during it, it occurs 65 years basically after they came in. Does that make sense to people? So we've seen state charts. We actually have gotten today a glimpse, a premonition, a sort of, there's a good word for it, but it's not coming to mind, a sort of a future glimpse of something we'll be seeing next time, which is agent communication via messaging. Here, the messages were sent from one state chart to another. And indeed, these state charts by and large execute more or less in parallel and independently of one another, but occasionally, ladies and gentlemen, we do want them to interact a little bit, or somewhat. So when someone is in diabetes, for example, it may influence their likelihood of getting infected with TB, or of developing active given infection. So we want the state chart to interact a little bit, and messages are one good way to do that. It's not the only way by any means. But next time, ladies and gentlemen, we will see messages used to communicate between agents. So one agent will communicate to another by sending that other agent a message. And indeed, we saw a glimpse of that in our very first encounter with AnyLogic when that infection is spreading. So we're going to see how those messages work, how those messages are routed to different state charts within an agent. So a person might get a HIV infection message and it goes to the HIV state chart. You're fired message, it goes to the employment state chart. A Hep C infection goes to the Hep C state chart. A transplant message, it goes to the kidney state transplant state chart, or what have you, and it routes them among the appropriate state charts within a person. We'll see that for next time, okay? Good. So thank you very much, and thank you for your accommodation with this. And I'm pleased we had a somewhat less entropic class today. We did more exploitation than exploration. Okay, Farhad, you have a model, ill model that needs.
I think maybe it's because of the software.
Yeah, I'm thinking the same thing too.